Sabi Africa. No Africa. No Africans. Pioneering role in science, engineering, and technology.
Sabi African Network, illuminating Africa's narrative as pioneers in science, engineering, and technology.
Indigenous reef fishing engineering and sustainable practices. Do you know? For millennia, African coastal communities have read tides like maps and built stone weirs, basket traps, and wooden corrals that channel water, direct fish, and protect nursery habitat. These are not folk tricks. They are hydrodynamic systems, gear geometries, and community governance tightly tuned to reef physics. Today, we will trace the engineering logic, the social code, and how those designs can inform sustainable blue economies worldwide. Industrial gears like trawls, seine nets, and motorized pushboats extract value fast but erode reef structure and reproduction. Coral reef fisheries supply food security for millions, yet the mismatch between extraction and regeneration is driving declines. Understanding indigenous reef engineering matters because it offers low-carbon, low-impact design patterns that were built to last in the same environments under pressure now. At its core, indigenous reef engineering uses 4 technical moves: guidance, physical leaders that steer fish, hydraulic timing, sinking capture with tides, selectivity, geometry and mesh that let juveniles escape, and anchoring, robust foundations placed on bathymetric features. Think fluid mechanics with stones and bamboo with design choices that maximize catch per effort while preserving the reef's productive function. Stone tidal weirs are a masterclass in passive hydrodynamics. Arcing walls funnel tidal currents into a narrowing pool. At high tide, fish enter naturally. As the tide ebbs, flow decelerates, and fish are held in depressions. No propulsion, no nets needed. The geometry, which is wall curvature, entrance width, and pool depth, is tuned to local tidal amplitude and reef slope. These are ecological filters as much as capture devices. Design principles translate across materials. Basket traps tune the aperture to target size classes. Corrals use staged narrowing to reduce escape. Modern adaptations keep these virtues but add durability. Treated local timber, modular anchors, and replaceable mesh panels. The key is preserving passive selectivity, allowing juveniles to escape, and maintaining ecological connectivity while improving lifespan and reducing maintenance costs. The hardware only works because of the software, customary rules. Local tenure, size limits embedded in nets, and ritual closures during spawning seasons. These are enforcement mechanisms that regulate pressure. Where tenure is respected, traps function like distributed marine protected areas. Harvests are predictable and spawning stocks recover. Social engineering and physical engineering are one system. These systems face technical vulnerability. Rising seas can drown carefully placed walls, storms scour structures, sedimentation alters bathymetry. Socially, market demand and motorized vessels can break tenure rules and overexploit traps. The engineering is robust but not invincible. Adapting requires both material science and institutional reinforcement. Practical pathways exist. Restore weirs where appropriate using archaeological blueprints and local knowledge. Reinforce anchors with rock or engineered modules to withstand storms. Modernize materials to reduce maintenance while keeping escape pathways intact. And critically formalize co-management, legally recognize customary tenure, and pair it with scientific monitoring. Hybrid designs can scale resilience without erasing local control. To be sustainable, these systems must also be economically viable. Ethical certification and premium market access, along with community-verified sustainable reef harvests, can redirect value to custodial communities. Tourism models that celebrate living heritage and local cooperatives that capture processing value ensure that stewardship translates to livelihoods. Ethical design aligns incentives with conservation. This is not nostalgia, it is engineering knowledge, a set of design patterns that thread hydrodynamics, geometry, and social governance into resilient coastal systems. Africa's reef technologies are ethical, low carbon, and deeply engineered. Map surviving sites, fund pilots that blend archaeology and modern materials, legally recognize community tenure, and link markets to stewardship. If we listen and partner, these ancient systems can lead a new chapter in global reef stewardship. Like this video, share your thoughts and subscribe for more deep dives into global history and science.